first thing I need to do. Yeah. Find the determinant. And our and our determinant is going to equal A times D minus B times C. In other words, our diagonals, 2 times 1, and the -3 and the 1. I'm going to switch these. Maybe I won't. Okay, so in this example, we're going to have D equals A times is 2 times 1 minus our B, which is -3. Our C is 1. That's 2 minus a -3, so we're actually adding 3, so our determinant is actually 5. All right, then to get our inverse matrix, the first thing we're going to do is we're going to flip our 2 and our 1, right? Switch these is our first step. Switch 2 and 1. So I'm going to have 1 up in this corner. I'm going to have 2 down here. I also already know it's going to be a fraction because we're going to put D underneath, so I already leave it space to have a fraction. These are going to stay in the same place. We're just going to change the signs on both of them. So rather than being a -3, it's going to be a +3. Instead of a +1, we're going to have a -1. And they're all going to be over the determinant, which was 5. 1 over 5, 3 over 5, -1 over 5, 2 over 5. And we now have our inverse. What happens if I multiply this by this? If I multiply my matrix by its inverse, what is the result? One person? 2 people? 3 people? Who knows the answer and is just not wanting to raise their hand because I'm going to call on them? Sarah?
1, 0, 0, 1.
It's the identity. That's the whole point of the inverse function. You have to know that. All right? Because on the test, if I did this to Sarah right now, if I said multiply this by this, you would just write the identity. If you're one of the people that didn't raise your hand and didn't understand that, you would have had to multiply this all out by hand when Sarah's on the next problem. So a matrix multiplied by its inverse is going to be the identity. And remember, that has to be commutative. So this times this also has to equal the identity. That's what we went over yesterday, that you have to go both directions to make sure it is the identity. Yes?
If we multiply 2 times 1, it's 2 fifths. If that's the inverse,
Okay.
and you said if you multiply that by that, then it's going to equal 1, 0, 1, 0, 1, right?
Right.
Doesn't.
Sure. Do you remember when we multiply the whole row
Yeah.
by the whole column?
Oh, you add them.
Yeah, we have to add them. So it's going to be 2 fifths plus -3 times that. So it would be plus 3 fifths will equal 1. 2 fifths plus 3 fifths equals. Yeah, 5 fifths, which would be 1. Yep, it works. It works. It'll work every time. Otherwise, it's not the inverse. So just remember, with multiplication, we do the whole row times the whole column. And then we move over and do the whole row times this whole column. I'd have 2 times 3. I'd have -3 times 2, which would be 6 fifths minus 6 fifths, which is 0, so it does work out. You have to know that, all right? That's something you have to just know. Don't spend the whole test figuring out that fact. All right. Also, if I ask you to prove something is the inverse, you have to go both directions. You should have a note in your notes. If you get that one wrong, it's just your fault, because I told you like 4 times to put a star by that. You have to go both directions. Okay, today we're going to talk about solving systems with inverses. So last time we used matrices to solve, we used the Gaussian method, the Gaussian elimination method, which boiled down to you do an augmented matrix, and you reduce it to the identity, and whatever's on the other side is going to be your answer. This one's different. We aren't going to use an augmented matrix. Instead, we're going to use matrix multiplication. So if I have ax plus by equals e and cx plus dy equals f, Gaussian would tell you to put that into an augmented matrix. If we're doing the inverse, we're going to throw it into a matrix multiplication that looks like this. We're going to take all of our constants and put it into one matrix. So I have a, b, c, d. We're going to put our variables in the next one, so that's x and y, and we're going to keep what equals into a matrix on the other side. And why this works, why we can rewrite this, is because if I actually multiply this, it's row times column, so it'd be a times x plus b times y. Well, that's exactly what I had up here. And if I come over here, I'd have c times x plus d times y, which would be our bottom row. So this is equivalent to this if you did the multiplication. All right, we're just going the opposite direction with it. All right. So then the most important matrix right now, we're going to call it M, is the one with the constants in it. So that A, B, C, D, and we're going to call it M. If I want to solve this equation, if I want to solve any equation where I have x's and y's in it, I always do inverse operations. Right? If I have 2 plus x equals 4, I subtract 2 on both sides. That's an inverse operation on both sides. If I have 3x equals 6, I divide both sides by 3 because that's an inverse operation. Well, with matrices, what we're going to do to invert everything is we're going to multiply both sides by the inverse of a, b, c, d. So that's why it says we're going to multiply each side by m inverse. And how that's going to look. So if I multiply by the inverse of m, it's going to look like this is a matrix inverse. We're going to multiply it on that side, and we're going to use the matrix inverse on this side, whatever it comes out to. Make a note in your notes. It has to go in this order. The inverse has to come first, and your solutions have to go second. So this has to go first, and these have to go second. Otherwise, most of the time you won't be able to multiply them. It won't work out. All right, so it has to be in this order. Remember, order matters with matrices. It's not like 2 times 3 and 3 times 2. If I put this like this, it's going to be a completely different answer than if I put it over here. So this has to come first. Sarah, what happens when you multiply a matrix by its inverse?
Well, it's the same.
It's the same. It becomes the... You said it before.
The identity.
The identity. Yep.
Gotcha.
So if I multiply a, b, c, d by its inverse, all we're left with is the identity. That's not the identity. That's the identity. 1, 0, 0, 1. And if I multiply a matrix by 2 numbers, remember this matrix just has numbers in it, by another matrix with numbers in it, I'm just going to come up with 2 new numbers. So J and K are just 2 new numbers, and I'm left with 1, 0, 0, 1, x, y. When I multiply the identity by something, so if I do row times column, I'd have 1x plus 0y, and down below I'd have 0x plus 1y. Well, that just leaves me with x and y. So when I multiply both sides by the inverse, I eliminate this, and I'm left with x and y, and whatever's on this side is my answer. All right, so that's all you have to do if you're multiplying by your inverse. I put a little note to myself. On the bottom that at the end of the day, what we're actually looking for is just x over y equals our inverse times whatever our e and f is. If I could draw an f, I don't know why we can't. So we don't have to really do this step here. We don't actually have to put the inverse on this side and cancel it out. I'll do it on the very first go around. But most of the time when you're doing this method, you're going to just find your inverse of this, and you're going to skip right to x and y equals that inverse times whatever these numbers are. Okay, and I'll show you what we kind of do. All right, let's go through this step by step. We only have one example, so make sure you follow along closely. So we are going to set up the equation as matrices. Note, we are not using the augmented matrix. This means on the test, you have to be very careful about how I ask you to solve it. If I say solve however you want to, however you want to. But if I say solve using inverses, you can't use Gaussian method. All right, you can't use that augmented matrix. So if it says solve using inverse, we first have to come up with our matrices, not augmented. So how we set it up is going to be, we put our coefficients in 1. We put our x and y here. Make sure everything's in proper order. Since x comes first and y comes second in both of these, that's why we do x and y. If we had a z, we would just put a z down here. All right, then that's just going to equal the matrix of our constants, which are 4 and -3. Now our whole goal is to find the inverse of this, multiply it both sides, and we should have our answer. So the very next step is find the inverse of the matrix with the coefficients. So that's this guy. We're going to find 3, -2, 2, 1's inverse. So we're talking about this guy. So the first thing we're going to do is we're going to get our determinant. That's going to equal 3 times 1 minus that -2 times 2, which is going to be 3 minus a -4, so that's really adding 4, so that's 7. All right, to get my inverse, I switch my a and my d, so that's going to be 1. Ooh, we're going to need fractions, so 1 and 3. And we're going to change the signs of our b and c, so that's going to be a +2 and a -2 in the bottom left. Then we put everything over the determinant, which is 7. So it's 1/7, 2/7, 3/7, -2/7. Is anyone struggling finding the inverse at all? Good. All right. So now I have my inverse. The next step is we're going to multiply both sides by the inverse. This is the only time I would write actually multiplying both sides, because we're going to see something cancels out. And so when I write out this whole thing where I multiply both sides by our inverse, I'm going to put my inverse in red. So multiplying both sides by our inverse, we'd have 1/7, 2/7, -2/7, 3/7, and we are going to multiply that by that original side, which was 3, -2, 2, 1, x, y. Mike, do you have a question at all?
I'm just working ahead so far.
Oh, okay.
Keep going, yeah.
Okay, good. You should be trying to work ahead because I work pretty slowly. And then, remember, we have to put our inverse first on the other side. Let's just shortcut that and copy and paste this guy. Oh, maybe this is not going to be a shortcut. This might have been a terrible decision. Okay, so we make sure that's first, and then we just have our two numbers on the other side, which is 4 and -3. Can someone tell me what happens when I multiply a matrix by its inverse? What do I get out, Jack? I get the identity. So in fact, this just cancels out. That was our whole goal. So like I said, most of the time I'm just going to skip to this x over y equals my inverse times whatever. I'm not going to write out this whole thing. It's kind of a waste of time because we created this to cancel out. So why I'm going to draw it and then cancel it out. That's why I created it. So most of the time I'm going to skip this step and I'm just going to go right to the x over y equals inverse times that. Now we just have to do that multiplication. We just have to do that multiplication. Remember with the multiplication we do row times column. Oop, I forgot to check to make sure it works. This is a 2 by 2. This is a 2 by 1. 2 equals 2, so I can do the multiplication. I want you to think about this really quick. If I would have put this in the wrong order, right? If I would have taken this one and put it here, I would have had a 2 by 1 times a 2 by 2. Can I even do that multiplication? Nope, you would have set your box up and you would have said they're not equal. So if you're doing this and you can't do the multiplication, you probably did it in the wrong order. All right? That should tell you a sign, oh, I need to put my inverse first and then my numbers second. Okay, so we do row times column. Our answer should be a 2 by 1. So we're going to have 1/7 times 4, which is 4/7, plus 3 times a negative 2, so that's going to be a negative 6/7. On the bottom, what color? Light blue, I guess. We're going to do negative 2 times 4 is a negative 8/7. And we're going to add a negative 3 times a 3 is negative 9/7. And we're done. Because x equals whatever's here, and y equals whatever's here, and that's why we have our solution down here. So x is just going to equal that 4/7 minus 6/7, which is a negative 2/7, and our y is going to equal that negative 8/7 minus 9/7, which equals negative 17/7, and we're done. If we have a 2 by 2 matrix, I do think this is the easier method to do by hand. Alright, because finding the inverse we said we had no trouble on. Versus, remember the Gaussian? Where we had to do every single row and manipulate it and go over and over. This is really just one step. Find the inverse. Well, it's 2 steps. Find the inverse, multiply. Okay? Hey, your calculators can do this for you. Alright, your calculators can do this for you. And what ones do we have? Let's go ahead and just look at 53 really quick. Alright, let's look at 53. So it says use a calculator to solve using that A inverse if possible. So all you're going to do is, and if I ask this on the test, what I'm actually asking you to do is set it up first. So maybe I have 1, 1, 1, 1, negative 1, negative 1, 1, negative 1, 1, times, well, I have 3 variables, so it'll be x, y, z, and that's going to equal 3, negative 1, 5. I am going to call this guy, let's go ahead and call it A, and I'll call this matrix B. Then in our calculator, I would just plug this in for A, plug this in for B, and then I would go to that home screen and I would pick matrix A, hit that inverse button, and multiply it by matrix B, and your calculator will spit out the answer for you. So that's just on those last 4, it says you can use your calculator. Because doing this by hand would be ridiculously hard. Okay, and I don't feel like doing all that. So we're just going to use our calculator for these 2. If your calculator spits out, hey, there's a problem with the inverse, it just means you can't take the inverse of it. and that's as far as we can go in this method, and that will be your answer. No inverse. Alright, so if I tell you use your inverse to find this, and your calculator comes up with an error, double check your numbers really quick. Alright, and then just say, hey, there's no inverse, so I can't use that method.